let's just get right into it then. Again, right,
Yeah,
so
for
this is
sure,
going
for
to be
sure.
medium levels. It's 4:05 right now. We have until 5. For a 50-minute
Mm-hmm.
target solve, we'll go to probably about 450, 455 if we have to push it.
That's
And
good.
because it's execution focused, I'm going to see how many problems we can kind of get through in this front. In this case,
Mm-hmm.
we're going to go through, depending on like the question, depending on the speed we go through them. We might go through a follow up on the same question, or we go to a different question.
Mm-hmm. Sounds good.
Okay, so let's get into the first question then. So in the first question, I'm
Mm-hmm.
going to write me a function called compress. Okay, it's going to take in a
Mm-hmm.
string. You
Mm-hmm.
can choose for the string to be a literal string or it can be a rare array of characters. That's up to you to decide. Okay,
Mm-hmm.
and the string is always. Oh, sorry, I got disconnected. Oh, I'm good. Wait, oh, I'm good now. Okay, sorry. And
Mm-hmm.
the string is going to be lowercase English.
Mm-hmm.
Okay, and you are going to compress this string. And here is the
Sounds
algorithm for
good.
you to use. Okay,
Mm-hmm.
you're going to find consecutive characters that are the same character. Okay, if this group of consecutive characters is length 1, you just append
Mm-hmm.
that one character to the output. Okay? Else,
Right.
otherwise, that means a group is at
Mm-hmm.
least 2 or more in length
Mm-hmm.
of the same character. Then you append
Mm-hmm.
that one character followed by the length of that group as a number.
Mm. I see, I see. Okay. Mm-hmm. And is that all?
Yeah, that is all. And then you can return the length of the encoded string.
I see.
Yeah.
I see. I'm just writing it down real quick. I see, I see. Okay. So, before we get started, can I just like repeat like the algorithm
Go ahead.
so that I
Yep.
understand it? So the algorithm is saying that for consecutive uh same length, I mean same characters of length one, I would just append it to the string. But if it's has like more than one consecutive character, then I append it to the character with the length of that sequence, right?
That's right. Yes. And the
Sounds
string
great.
only contains lowercase English.
Yeah. Okay. Sounds great. Okay. This does seem like a straightforward question. Um, what I can do or what I'm planning on doing here um is to go through this through the string one by one, one character by one character, and then for each character, for each character, I would just start counting how many of the same characters are in the sequence. And from that, I can just do like a condition checking. If it's more than one, then I would append the character with the length. But if it's just one, then I can just append the character. Does that sound like a logical approach to you?
Yeah, that makes sense.
Sounds great. Okay. Um, sounds good. Sounds good. Yeah, so with that said, I think I can just jump in to writing the functions. Uh, yeah, okay. So let's say I have an encode function that takes in a string like you mentioned.
Yep.
So that would take in input, for example. Okay, so we know that. So I'm just writing out some example questions that I would understand better as well. So if it's A, B, C, that would become just ABC, right? It just becomes the same string. And
That's right.
then
Yep.
AA, yeah, sounds good. And then AABC, that would become A2BC.
That's right. Yep.
Sounds great. Okay. Okay. So yeah, I'll just write down what I'm trying to do so that I don't forget. So what I'm trying to do is that for loop through the character, and for each character, I can just assume that it's the start of a consecutive subscription sequence. So assume that each the start of the sequence. Um, and then count how many same characters in that sequence. Uh, Characters, if I can spell. And then uh, check if I should add length or not. Okay, sounds good. Uh, okay. Yeah, I think we can start coding this up. Do you have any questions on what you want to clarify
No,
before
that
I
makes sense.
start? Or
No, that makes sense to me.
sounds good, sounds good. Okay, so yeah, I'll just do a simple loop through the string. Let's see. I'll just record the length of the string first. Um, yes. Let's see. Okay, so I'm just looping through each character of the string right now. And for each character, I'm gonna assume that uh it's the start of the subsequence. So let's say I keep track of like the the character in question. So I would
Okay.
keep track of yeah, I would keep track of oh sorry, target for example. I would keep track of the current character and then say so then I would say as long as the current character that I'm checking is the same as the target, I can increase the length. So that would just mean oh, as long as the current character is the same as the target, then I would increase the length, which I'm gonna have here. Um, yeah, I would increase the length right here. Um,
Okay.
yeah, to make this okay, so I also need to like keep checking the characters, right? So I would just increment. I would first check grab the current character, check with the target, and then increment the maybe I shouldn't increment it actually. Maybe I should not. Yeah, maybe I should increment in here. Yeah. Uh, sorry. Uh, so yeah, just, sorry about that. Wait, let me gather my thoughts again. Yeah. So I would check for every characters after the current character. So okay, that would just increment as long as it's the correct one. I would just increment to the next one.
Okay.
Um, yeah. But here's like the caveat of this approach because let's say I have um A, B, C, for example,
Yep.
the pointer would point to B. Yeah, the pointer would point to B before um the pointer would point to B, and then when I loop again, uh this I over here, the for loop increments would increase to C, and I would accidentally miss a B in there, and I shouldn't do that. And in addition as well, that I just found out is that I'm not doing like checking for I'm not doing checking for the bounds here as either. So if I keep increasing, I might go out of bounds. So it's a little bit careless on my part here.
Okay.
So is what I could do is I could check that there are actually characters after it. So I would just check that there are still at least n minus one. Oh, not sorry. There are at least some characters after it, and I would just check it. I would just make sure that I is not n minus one yet, and then I would also check that the next character is equals to the target. Yeah, so I'm checking that the next character is equal to the target, and I'm checking for the bounds here as well. Um, okay,
Okay.
that makes sense. That makes sense. And if I'm correct, this should this should cover like the caveat that I just mentioned, because if the next character is not the same, it doesn't increase the index. And let's also check for the bounds here. So yeah, so that should cover the caveat. And now all I need to do is that I just need to check if the length is well, let's say I have the encoded string for rest, for example, for result, and I first ask um so for every scenario I would just add the target character. So I would just first add the target, and then if the length is larger than one, then I would also add the um, um, the length as well. That said, am I allowed to do this? I think I am. And then all I need to do is to return the result. And yeah, I think that should be it. So just simply summarize this
Mm-hmm.
this for loop real quick,
Yep.
is that I'm taking the current character, I make it the target, and then I would just loop through all the all the characters that are the same to the current target, and then I would add the target to start encoding it. And if the length is larger than one, I would also add it as like part of the encoding algorithm. Does that does that look like it's a good
Yeah, that makes sense.
execution?
Yeah, that
Okay,
makes sense.
sounds great.
Um,
Sounds great.
let's talk about the time and space complexity of this method.
For sure. Um, the I'll just go from from the outer loop to the inner loop. Uh, so for the time complexity, we are going through each character at most once. So this, because like since this inner loop is also increase the index.
Mm-hmm.
So if the loop keeps increasing the index, like the outer loop would not have the chance to check it again. So that's why the entire loop, the entire for loop, will check the entire for loop and the while loop will check the each character at most once. So because of that, we get an O of n time complexity. And yeah, so O of n. And then for the space complexity, we are creating a new string. Uh, we are creating a new string, and because okay, for the new string, it has the length of the new string is at most the length of the input. So because like if they are consecutive characters, it would reduce to only one character plus another character for this length, right? So the most characters in there would be the input, which is like every character
Yeah.
every character appears once, or every character appears at most twice. Yeah, so like if it's AA, it would we would the encoded string would be A2. So yeah, so like the space complexity for this would turn out to be O of n as well. And yeah, does that make sense?
Yep, that makes sense. What's the optimal?
That's great.
What's the best case space complexity?
Best case space
Yeah.
complexity. Best case. Mm, the best case space complexity.
Yeah. In other words, there exists
Uh,
an input
yeah.
which minimizes
Mm-hmm.
space complexity. Correct.
Mm-hmm.
Given that
Yeah,
input, what is the
that
space
makes sense.
complexity?
Give it like the best input, right?
Yes. What is the space? Well, best in terms of
Yeah.
space complexity, not necessarily anything else.
Mm-hmm. Yeah. Okay. So my intuition is saying that if we get like all characters the same,
Okay.
it would reduce to only A2, A and the length of it. So the best case would be O of one because it was just the character and the number. Well, that's actually not true. That's actually not true
Okay.
because we could have infinite number of characters in here, right? So the best case in complexity would be
We can have in characters in there by definition.
yeah, we could have n characters in there. And because like the length of the encoded will will depend on the number of digits of the length of the number of digits of n as well.
And what
So
is
I
that?
guess, and if I if I'm doing the math correctly,
Okay.
that would be log base 10 of n because of the number the number of the is it log base 10? Yeah, it should be log base 10. Like it's the number of of 10 of the number of the number of tens
Sure.
for because like for one digit to increase in the next one, it needs to be multiplied by 10 essentially.
And so therefore
So
the
it's
space complexity is
uh O of O of log n.
okay. Okay.
Yeah,
Let's put this aside and move to the next question because we got quite a bit of time.
that's good.
So let's start next
Mm-hmm.
question. This is going to be a binary tree question. Okay. So let me give you the
Mm-hmm.
definition of a tree node.
Mm-hmm.
Okay. So this is going to be a question. This is going to be a question where I ask you to write me a function. Okay.
Mm-hmm.
And in this function, you're going to take in the references to two binary trees, the roots to two binary trees. Okay.
Right.
And by the way, these are binary search trees. Okay, so not just
Okay.
binary, they're specifically binary search trees. Okay, and
I see. I see.
and I want to return me a list of integers, and this is a binary tree of integers, right? Int val. Return me a list of
Mm-hmm.
integers that exist in both trees.
That is this in both trees.
Yes.
Ooh. Okay. I see. I see. Hmm. A list of integers that exist in both trees. Well, that's a really interesting problem. Okay. A list of integers that exist in both trees. I there are a couple of approaches that I could go about this questions. Do you still see my mouse
I see
here,
them.
like
Yeah.
in the main function?
Yep.
Okay, sounds good. So I'm thinking, um, like not the best approach, but the most obvious approach here that I could take is to traverse through both trees and then record like the oh, before that, like are the nodes, are the numbers within those trees unique or uh are they guaranteed to be unique or
What do you mean unique?
can they be like let's say if in my tree A
Yeah.
I would have can I have three and then its left node is its children node would be also like three and three or um can
Uh,
it be like uh, one, two, three?
yeah. Duplicates are allowed
It has
in
to be one,
binary
two, three.
search trees. Yeah.
I see. And if in the case of duplicates,
It's always
do we
if
sorry?
it's a duplicate, we can assume it's always in the left subtree.
Sounds good. Always left. Always left. And do we I'm just verifying like the output here. So for the list of ints, do we care about like all like the correct number of duplicates? Like they have the same number of like threes and the same number of threes in the other tree as well? Or do I just return three?
If both trees contain two threes, then you would need to return two threes. If the
If
first
both
tree contained two
okay,
threes and the second tree only contained one three, then you should only have one three in the output.
I see, I see. Mm-hmm. Sounds good. Okay. 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 Sounds good. Yeah. Thanks for clarifications. Um, yeah, sorry. I was in the middle of something and I got sidetracked. So yeah, so like I was talking about the obvious approach that I could do here is that I traverse through both of the trees and record like the number of like what appears in each of those trees with a hash map, for example. So I would count the number of like threes in tree A, the number of threes in tree B,
Mm-hmm.
and then I would take the not the difference, the minimum frequency of the two of them, and make sure that um they both appear in both trees. So that could be my approach. But I'm trying to think if there's like a more clever approach because after all, this is a PSD tree. So say for example, binary search tree. Are they guaranteed to be balanced or anything?
No,
No. Okay. They just binary search tree. Let's see.
that's right. Yeah, just binary
Hmm.
search trees.
Okay. Because I was thinking if my tree A has one, yeah. If I want to show you as well. So one, okay, this gonna take a while, but okay. So if I have 1, 2, and 3, so that let's say it's a straight line down.
You can use a
Um.
drawing pad if it's easier. There's a drawing pad on the left. You can access.
Oh really? Oh really? Oh
Yeah,
nice.
like
I
this.
didn't see that. Oh nice.
I'll clear it.
Okay.
Go ahead.
Yeah. Sounds good. It's also so hard to draw it on tablet though.
Yeah, it's not easy.
Okay. Okay. If I have 1, 2, and 3, and say, oh, on my tree, right, I have 2, 3, and 1. Am I guaranteed? Is there anything that I could guarantee in here? So let's say we both start out in the root.
Yep.
So 1 and 2. I'm gonna check the next. So I know that these two don't match. So these two don't match, but I cannot immediately say that 2 doesn't exist in tree A because 2 is larger than 1. Hmm.
Is there a particular traversal you can use?
Right, 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 right. Yeah, I could totally do a pre-order traversal to, because like for BST, the pre-order traversal is in order, right? So like if I have 1, 2, 3, 4, 5 in the tree, and no matter what shape it is, I would also get 1, 2, 3, 4, 5 back as the sequence of it. Oh, I see. That's actually a very good hint. Thanks. So, okay, I see.
Mm-hmm.
But if I were to do
A
pre-order,
pre-order. Do you
mhm,
remember the difference between do you remember the differences between them?
between pre-order and other traversal,
Yeah. Do you remember the differences?
yeah. So for pre-order, it's like left, like the child. Oh shoot, you're right. It's not pre-order. Left node and then left node. Wait, sorry. I'm actually okay. It's left node, right node, and then root node. And then post order is wait, no, no, I'm actually yeah, I'm right. Sorry. Wait, I'm actually so tripping right now. Sorry, give me a second to get my thoughts here.
You can
So
use the second tree as an
three,
example. Yeah.
yeah,
So what would
yeah,
pre-order
okay.
give you?
Yeah. So pre-order should be root and then left node and then like right subtree and left subtree and right subtree.
Yes.
And post order would be somewhat of the opposite. So it would be left subtree, right subtree, and then root. And yes, you're right. It's because we right, left, right. Because
Post order would be fruits, left subtree, children, then right subtree. So in this case, it would be the same, but yeah, that's not what you want either.
yeah, yeah, neither one. I wouldn't want neither one. You're right. So I would want what I actually want is in order.
Yes.
Yeah, that's why the name comes from. So that would be one. So that would be left subtree, root, and then right subtree. So that would give me the sequence of 1, 2, and 3. Yeah.
Yes.
Okay. Okay. I see. I see. Okay. I was being a bit too hasty there. Yeah. So let me double check on this tree as well. So it will be left left subtree. So I don't have any. So root, right subtree, and right subtree. Okay. Yeah. So okay. Sounds good. So that would be 1, 2, 3 for both of them. Okay. I see. Um. So in that case, I would have to, okay. So in that case, the thing right now is like, how can I traverse? do I do the same strategy to traverse both of them and then store the vectors? That would defeat the purpose of like why are we doing this? Is there a way that I could? I'm just thinking out loud here, but I'm just
Yeah.
thinking like if there's a way I could like sync up the traversal and I could start traversing. Um, yeah, I could sync up the traversal with this. Um, hmm. Yeah, how can I sync up the traversal for this? So I would go. So if I do a normal recursive type of traversal, I would first check the left one first, the middle, and the right one. So do I traversal when they are not the same? Hmm.
Well, maybe another question you can ask is why do you want them to be synced up?
Why do I want to be synced up? Hmm. I want them to be synced up because I could eliminate because I'm thinking of eliminating. Right, you're right. Because I was trying to see if I could like do uh a branch pruning to see if like if for some reason like I'm at two and I know that one wouldn't be in the other tree, then instead of like checking the left subtree, I can just prune it completely and check the right subtree instead.
Yeah,
Just if that makes sense.
that makes sense. And what's your condition for
But
knowing
yeah,
that the other tree doesn't have anything less than two?
if anything is less than two, um, so if I have so let's say I have um four, eight. If the other one doesn't have anything less than two,
Yeah. In other
the
words,
other one doesn't have.
um,
Mm-hmm,
the reason you want to keep things synced up is because you want to know which way to iterate,
mm-hmm,
right? So you
yeah,
need to compare,
mm-hmm,
right? Like you need to compare, your first tree's current node versus the other tree's current node. And based on
mm-hmm.
what
Makes
condition
sense.
do you iterate?
When you say iterate, do you mean like
Yeah,
traversing?
traversing. Yeah.
Okay, conditions I iterate. Um, ah, right, I see. When they don't match is what I'm thinking here.
Yeah, they don't match. If it's greater, if A is, if you call the left one A and the right one B, if A's root
Mm-hmm.
is bigger than B's root, what do you do?
If A root is bigger, right. Uh, I see. If A root is bigger than B root, then you would traverse down to the left side of A. That's yeah. If A root is bigger than B root, then you traverse that down to the left side of A. And does that sound correct, first
Yeah,
of
that's
all?
one way you can do it. Yeah.
Okay. And if A root is less than B root, if A root, so if this is 1, if A root is less than B root, do I traverse down B? I could traverse down B. Uh, yeah, I could traverse down B to keep tracking, to keep checking for B side.
Yeah.
Oh, I see. I see. Okay. Okay, I see. And if A equals B, if the root of A is equal to root of B, then I would just also traverse down to the left side of both sides. Yeah, of both sides. I would traverse down the left side of both sides because there could be duplicates. Does that sound
Yeah.
correct?
That sounds closer. Yes,
Okay.
that's right.
Okay, sounds good. Um, my only problem, the reason why I feel like the reason why I had uh a lot of trouble trying to think of like what how I can sync this up is because I was trying to do it with recursive, but I can't really how do I explain this? Like I can't really do recursive on A and then pause it and then do recursive on B. Maybe. I don't think I don't think I could find a way to do that. So what I could do is that I could do a just a stack, like just a iterative approach
Yeah.
to recur iterative approach here using stacks. Does that sound more right on track here?
Yeah, you can. I mean, keep in mind that yeah, like yeah, you can use a stack for that. Stack to imitate a recursion stack because you're putting the parent onto the stack and you're popping
Mm-hmm.
you like or not parent, but you're putting the current node on the stack. And if you're just
Mm-hmm.
repeatedly doing that, that's the same thing as recursion, right?
Right.
But yeah, like you
Yeah.
could do it that way. Yeah,
Okay.
it would be okay.
Okay. Okay. Sounds good. But then again, if if I were to do it with this with stacks, I would have to also I would also have to like have another headache of uh I would have another headache of like if I visited node if I already visited a node or not because I would have to push the root back to stack and then push the left node on top of it and so on. So maybe maybe sorry, let me take it back. Maybe I'll stick with recursion for now and then we can see how it goes.
Okay, sure.
Sorry about that. Yeah.
Yeah, sure.
Okay. Okay, I'll just do define the functions real quick. So we want to return a list of integers, right? So let's say we have like general functions that take in that returns a vector. Oh shoot. Okay. Um. Okay. So to return a vector, so this would be find common, for example, and so I would get a tree node uh root A and tree node root B. Okay. Um. Okay. What can I do here? So like we mentioned, if they both not equal, I mean, sorry, if if A is less than if A is less than B, then B traverses down to the left side of it. If A is larger than B,
Mm-hmm.
wait, no, yeah, if A is larger than B, then if A is larger than B, then A traverses down to the left side of it, and if they are both equal, you also traverse down to the left side. But then what about the right side?
I
It
think
could also, oh,
I think this
mhm,
is I think you're getting a bit confused about the mechanics of a tree. Um, the like we discussed, right? The in order traversal of
mhm,
a binary search tree gives you the elements in non decreasing order,
yeah,
right?
mhm,
So
mhm,
so you have A and B,
right,
and you're traversing them. You have a way to traverse both in non decreasing order.
mhm.
So there's no left or right. It's just next.
I see. Sorry, but in this case, I still haven't found a way to like prune the tree either, right? Like I don't see a way to, I don't see a way to like cut a certain branch off. Because like if A is not equal to B, like there's nothing like decisive to tell me that you can't cut a branch off. Wait, let me think about it. Because
That is technically true. In the in order traversal by default does not have pruning, right? I
right,
recommend you don't try to prune anything. and you just do the naive in
Mm-hmm.
order traversal.
Right, I see. But okay, but in that case, if we're not pruning anything, like uh instead of me trying to figure out or like trying to remember how to do the traversing, I could also do like no the normal like the obvious approach of traversing only one tree first and then traverse the other tree and check both of them, right?
You could do that, yeah. You could do that. I mean,
Okay,
yeah, you can start with that. Yeah.
okay, okay, sounds good. Okay, back to square one then. Sorry about that. So okay, so okay, if we just go with like the naive and approach um uh the naive and obvious approach, then we can just do like I can do any kind of traversal for that. Like I could do either if a search, pre-order, post-order, or well yeah, or just a level order as well. So let's keep it simple, and I wanna use yeah I wanna do I wanna do a level order traversal instead. Um, which is what sorry, level order. Yeah, level order traversal.
Okay.
Because I uses a queue and yeah, yeah. So yeah, so sorry. So what it can do is that let's say I have a uh count counts nodes, for example.
Mm-hmm.
I have a function called count nodes, and I would take in a tree node, um, and a reference to and a reference to a count the counter, which is like hash map, for example. So let's say I have a hash map that maps from the value from one value to the frequency. So I would call this frequency, for example, and I would have a reference to it. What I could do is that I can create a the hash map here. I'll call it frequency as well, and then I can pass both nodes or like one node at a time to the functions and
Mm-hmm.
count the frequency and then take the difference between the two of them. So what I could do is I could either create a new hash map or I could be yeah I could why not create a new hash map? Doesn't make that much of a difference. So I could do count nodes for root 8 A for example and then frequency A, and then I would also do the same thing for root B and then frequency B. So frequency A and frequency B now would contain the result of um, yeah. Frequency A and frequency B would now contain the result of like the frequency of each value of
Okay.
each unique value in each node in each tree. Then what I can do from there is that I could iterate through one of the counter to one of the hash map.
Mm-hmm.
I see pair for example, and then I would check if the value is in the yeah I would check if the values is in the auto map and which one if it is then what is like the most common if there is like if there is like how many duplicates do they share? Does that make sense so
Yeah,
far?
that makes sense.
Yeah. Sorry, I'm just trying to speed through
Yeah.
to make up for the time that we lost. So all I need to do right now is that so I would check if A is if B has whatever A's has. So if it's less than I go to you know yeah I could also do this. Oh, no, I shouldn't do that. Okay, so if B I would check if B has the value of A uh the less than go to the end of it So if it does, then I can push back the the number of duplicates that they share, and the number of duplicates would be the minimum between the two frequency.
Yep.
So that would be p dot second as well as frequency b of b dot first. So yeah, so I would just push back. Ah, sorry, this is not going great. So I would also check. uh, I shouldn't be pushing back the frequency. I should be pushing back the value itself, the number of value itself. I
Yep.
see. So I would do a um I would do like uh, let's call it let's call it nums for example, and that would be the minimum, the frequency.
Okay.
And I would call num frequency for example, and I would check as long as there are some frequency, some duplicates left, I can just push the value into the result array. So I could do that by do p dot first. Yeah, and this should fill up the right number of duplicates.
You need to
Um,
decrement num frequency, right?
there you go. Yeah.
Okay.
So yeah, it would give us the right number of duplicates. And do you want me to code this one now as well,
That's fine. We
or
can skip that. And for this
okay,
function, you return res at the end, right? Okay. Let's go through
yeah,
the time and space for this problem.
mhm. Yeah, definitely. The the time complexity here, most of them would take around these uh oh sorry, am I okay? Most of them would just take around these two function call. Well, that's quite not quite true yet. But the count nodes, since it's going through all the nodes in A, and the count nodes also goes on through all the nodes in B, the overall time complexity of these two steps here would be would be the maximum would be the maximum time that to go through A or B. So let's say if we have let's say if we call if we denote small a as like the number of nodes in root A, and small b in the number of nodes in root B, we would have the time complexity here as max of A and B, for example. Does that make sense so far?
Yep, that makes sense. And
Sounds good.
what's a like? Are we assuming in this case that it takes linear time to traverse the tree?
Yeah,
Okay.
yeah, yeah. We going each node only once,
Okay.
and yeah, and so for this, it's basically the same as well, because since we're going through like the frequency of each node, of each unique value, it's essentially going through the same number of nodes again. So that would just be that should have the same that should have the same complexity as these two functions here. So what we would have is a maximum of A and B as well.
Mm-hmm. Yep.
Yeah, so like the overall time complexity would be the maximum the maximum number of nodes in either tree. And for the space complexity, um, since we're storing unique values and a tree can is incidentally have only unique values, uh, we could like store up to the number of nodes. And since we have two different trees here, it would also be the same. Like the space complexity here would be the maximum of the number of nodes in root A or the number of nodes in root B as well. Yeah, yeah,
Mm-hmm.
for space. And
Yeah.
yeah.
And well, it would be in this case. We could be more precise. Say the space would be A plus B.
Oh, shoot. Yeah, yeah, you're right.
That would be true for both time and space.
Mm-hmm.
But yeah, technically, O of max is still technically correct. Um,
Mm-hmm. I see.
yeah. Okay. Yeah. Yeah. That makes sense. Let's stop here. Because
Mm-hmm.
there's a lot to talk about in this one, right? This is a probably a more interesting question we
Yeah.
haven't seen. Um,
Mm-hmm.
I kind of have to start this off by just asking you. By the way, right? There's two questions here, right? The second question was about basically finding the common value between two trees, and the first one was about the encode question. Encode, I don't think there's much
Mm-hmm.
to talk about. I think you solved it basically optimally, so I don't think there's anything to say there. Let's focus the time
Mm-hmm.
on the second question. Is there anything about the
Mm-hmm.
first one
Sure.
you wanted to talk about before we moved on, or can we just move on?
No. No.
Okay, then yeah. So how do you feel about the second one?
The second one's, I feel like the intuition is definitely very obvious here. I could definitely code this up and like this one up like in like really really fast.
Mm-hmm.
But yeah, it's either so that's why I kind of got. It's not that I got cocky about it, but I feel like I could have done a little bit better, and I
Yeah.
feel like it would be more interesting for me to start thinking about the optimal way instead.
Yeah.
But I'm not sure if that's the correct approach here because I feel like I kind of led the interviewer like you around a little bit, and it's a little bit confusing.
Okay. Yeah. I mean, the main thing about the question here was that there was some confusion at the beginning about how you wanted to proceed, right? And so I
Hmm.
mean, okay.
Yeah.
First of all, by the way, you got to know the order traversals, right? Like pre-order, post-order,
Yeah.
end order. Like level order is basically
Yeah.
overused to be honest, but like pre-order, post-order, and end
Mm.
order, like you have to know them.
Hmm.
Like there's no excuse, right? Like you have
Yeah.
to know them. So
Yeah. That's true.
right, this one, like if you use pre-order traversal for this one, it would just be incorrect.
Hmm.
Like it just wouldn't work, right? There's no way to
Hmm.
make pre-order traversal useful in this problem, really. Okay.
Yeah, definitely.
So in order traversal, right? Remember, like the in order traversal, as you pointed out, right? It traverses the binary search trees in order, in increasing or in non-decreasing order, right? That's
Hmm.
the purpose of the in order traversal, right?
I see.
Right.
Hmm.
And
Yeah.
so the purpose here is that you had a strong intuition for traversing the two trees together. Okay. Why is that?
Hmm.
Because this question, when I say this, right? If you traverse two binary search trees in order, this question is merge linked lists. Have you solved that
Oh,
question before?
yeah, I
Right?
remember. Yeah, I
A
saw it.
binary
Yeah.
search tree. If you traverse a binary search tree in order, that's a sorted linked list.
Oh, that's why you hinted there's only next and not left and right. Ah, I see.
Yes, because well, if you do, I mean, if you think about in general about traversals, there's only a next. Like there's no traverse left traverse right. It's just next, right? That's what
Hmm.
traversal means in this context. Um, and so yeah, if you do an
Hmm.
in order traversal on a binary search tree, it becomes a linked list. Do you see
Hmm.
what I mean? And so this
Yeah, I
question
see.
essentially becomes find the common elements in two sorted linked lists. And I think if that was a question
Oh,
given to you, you would solve it much quicker
right. I
because
see.
all the same stuff would apply, right? Now the intuition here
I see.
for how do we actually so there's now okay so from here there's two things I want to talk about.
Hmm.
They're separate. Okay. The first thing
Hmm.
is the first thing is I'll get this out of the way because it's a bit controversial. Okay. C++
Hmm.
is definitely not. It's definitely got some sussy stuff going on here. Okay. Two notes. First of all, this took you about 5 minutes to write. Okay. In Python, this
Yeah.
is two lines. In Python, it looks like this. There, that's Python. You intersect two dictionaries. That's what it looks like. Okay.
I see.
So C++ here is definitely holding you back a little bit. I know you were doing you. I know that you were a bit nervous, a bit of a time crunch, but keep in mind that
Hmm.
when if you find yourself solving questions that you're struggling with the mechanics of, that's a sign that it's worth more and more investing in a language which can solve that more quick, more quickly, right? Because
I see.
in a time crunch situation, you don't want to be like you don't want to be writing this, right? Like this is error prone, and stuff is going on. Okay, so
Hmm.
that's one thing to keep in mind. Okay, the second thing I want to keep in mind
I
is
see.
I don't. By the way, I don't actually know how familiar you are with C plus plus.
Hmm.
Do you is C plus plus your primary language, or do you use a different language for your projects or coursework or what?
I use C++, basically my primary, like
Okay.
for leetcode. So
Do you know about generators?
generators? No, I do
Okay.
not actually.
So let me show you something. Okay, so look at the tree node struct right now. Okay, now I'm gonna of course I'll save this code for you later so you can copy it, but
Hmm.
okay, hold on. Let me explain what's going on here. This
Yeah.
solution is not optimal. The reason it's not optimal is because you are using a plus b space, and it's possible to do
All
this
right.
question in log a plus log b space. In other words, you don't need extra memory except for the traversal itself. And the
Hmm.
reason that's the case is because remember, right? If you're traversing, if you're marching two linked lists side by side, why do you need more memory? You don't. So the only
Yeah.
memory
Makes
needed
sense.
is to traverse the tree to make it a linked list. Okay.
I see.
Um, the
Okay.
difference between traversing the okay the difference between traversing the nodes and then sorry, traversing the tree and collecting the node frequencies, the
Hmm.
downside there is that you have to store all of the frequencies, right? This is where your space complexity comes from.
Hmm.
If instead of that
Makes
you
sense.
were able to generate the next in order element in a tree, you wouldn't need to count the frequencies. And so now, I want to just be clear. I'm not a C++ writer, but what I can say
Yeah.
is that a generator will look something like. Let me think. I think it's called generator no int. So you generate int, and then the function
Hmm.
is called in order, right? Like the by the way, so like this is inside the link up here. So I recommend you study that, okay? And
Right.
this is very so this will be what if left if left. Oh right, yeah, and then so you know what? I'll copy this because I don't actually need to invent the wheel here. The different okay, why is this important? This is important because this basically gives you elements on demand. Oh, it's supposed to be like this.
Oh.
This gives you elements on demand,
Oh.
and the reason
I
that's
see.
significant is because if you have if you have a reference to an instance of a generator for a tree, you wouldn't need to
Hmm.
traverse the entire tree at once. You would only need to traverse it on demand,
Right.
right?
That makes
And
sense.
so what that lets you do is this question literally becomes merge two sort of linked lists or find common elements in two sort of linked list, right? Like let me just do
Right.
let me just do a bit of pseudocode here, right? Like just for the sake of argument, just for
Hmm.
void f tree node a. I'll copy your code here, right? So you'd say I don't know what's called auto generator a equals a what is it called? Traverse in order, right? How do I resist this,
Oh, I see.
right? And then you would just say, okay, so I have so right, so generator. Oh, I need
Hmm.
semicolons. I haven't written C++ in like years.
Hmm.
Um, I think it's next or whatever. It doesn't really matter. Right, like
Yeah.
you would get
Makes sense.
right, like you would just get two heads, right? So you would say so right, so auto
Yeah.
cur a, right, cur a, cur b,
Hmm.
right?
Hmm.
Whoops,
Makes sense. Yeah.
right. I'm trying to just demonstrate the point here. Why
Yeah.
is that right? And then if you and now you say okay, so for example, right? So check if equal blah blah. I don't care about that, right? So then say if
Hmm.
cur a is less than cur b, right? Then we do cur a equals cur a dot next, right?
I
And
see. I see.
else do the other way around, way, right?
Hmm.
Else
I
else
see.
stuff, right? Whatever. And then the
Hmm.
point here is that you check if they're equal. If they're not equal, you just increment the one that's lower, and then
Hmm.
you check if they're
That makes
equal,
sense.
and vice versa, right? And the
Okay. That
benefit
makes
here
sense.
is that this right here, right? We're not actually using any extra memory here,
Hmm.
right? So all we're doing
That
is
makes sense.
we're just requiring that we have a pointer towards the next one, and so the maximum memory here is
Hmm.
just the memory used to iterate. It's just the memory used to iterate through the tree, which is the height of the tree, right? Like that's the maximum call stack,
I
which is
see.
log a or log a plus log b,
I see.
right?
I see. Okay.
Um,
That makes a lot of sense.
yeah, and then I'm not doing all the housekeeping here, but you know, I mean,
Mm-hmm.
I'm not counting the result as part of the memory complexity because that's just required output, but that's kind of how it is.
Mm-hmm.
Okay,
Okay, makes sense.
that's the main piece here. I think you missed, but the solution you came up would
Mm-hmm.
still work. It just wouldn't be optimal. And I think as long as
I
you
see.
recognize, like for example, if you did that and then you recognize that it wasn't optimal, I think that would still be like a relatively strong performance. But I
Mm-hmm.
think the main learning here for you is that you need to recognize when a specific approach isn't going to pan out, and that you should default to something easier, right? Because for
I
example,
see.
had you just written this easier naive solution first, you would have had time to also implement your like your traversal almost certainly, right? And
I
that
see.
would look more complete in that sense.
I see. So I see. That makes sense. So so I guess this kind of circles back to like my question at the start. Like so like how do you think my approach there was like because I was like I know that my approach wasn't optimal. I know that there's something that I'm missing.
Yeah.
So I tried to like play around and try to experiment a little bit. So
Okay.
was that the right approach? Like should I have done that or should I have just like okay, I'm just gonna write out the naive approach right now and then I can come back and optimize it later.
Good question. That depends on two things. The two things that depends on is how confident you are in your ability to find a more optimal solution, and
Mm,
how what your estimate for how long it would take you to write the naive implementation, right? For example,
I
in
see.
this case, if you think it only takes you 10 minutes to write the naive implementation and you
Mm-hmm.
haven't thought of like a good optimization or you're not confident in it, then I would say
Mm,
write the naive solution, and while you're writing it, spend that time thinking about, if you can, spend the time thinking about how you can optimize it. Okay,
I
because that's
see.
like an insurance
I see.
policy, right? In most
Mm-hmm.
cases, I'd say it's only worth going straight to the optimal answer if you have there of two things. If first of all, if you can bail easily, right? So you can bail easily if it's not that different from another solution, then it's okay to risk it.
Mm,
Or
right.
if you know that it's too big of a discrepancy between the optimal one and the naive one,
I
right?
see.
Like for example, if it's a relatively if it's a company that you're trying to interview for, and
Mm-hmm.
it's a company with relatively difficult interviews, right? Like they're asking difficult problems. You get
Mm-hmm.
0 points. I'll be honest, like you get 0 points for writing a naive answer because that's not the point. Like that's not the skill, right? In that
Mm-hmm. I see.
case, it's worth it to risk it. Like you should have a higher risk tolerance threshold to try to get the optimal
Mm-hmm.
answer because writing the naive one perfectly will not pass you. Like you will not pass.
I see. I see.
So that is a bit of a
Okay.
judgment call, but you should have that call going into the interview. Then decide on the spot
Mm-hmm.
is it worth risking, right? So
I see. I see. Okay. That makes sense. And okay, sounds good. And sorry, just like one quick question about this as well. For the generator part here,
yeah,
that would require me that would require me changing the structure of the tree node, right?
yeah, it would.
If
Yeah.
if I wasn't allowed to do that, like I'm sure that there's still a way to do this pretty it's not too bad, right? Like there
Um,
should be a way to do
well,
this.
I see. So here's why I can't really help you. I don't really know C++. In languages
Right.
I know, like Python, JavaScript, Java, you can write your
Mm-hmm.
custom iterator, which is essentially a generator. So in
Oh.
those languages, it's trivial. You can just pass it a route, and you
Mm-hmm.
can just call next on it. Like if you think about it, right?
Oh, I see.
If I gave you a question, this is not related. If I gave you a question, okay,
Mm-hmm.
uh,
Mm-hmm.
make a class, okay, construct cons, uh, take a tree root, okay, implement
Mm-hmm.
next, give next in order element, has
Oh.
next, return true if only blah, right? This is what you're implementing,
Mm-hmm.
right? Like if you had to implement this, this would be relatively trivial. So I don't know in C++
Yeah.
how it works, but I'm sure it's possible somewhere.
I see. I see. I see. Sounds good. Well, thank you so much.
For sure.
That makes a lot of
Yeah.
sense. Yeah.
Yeah. By the way, in the sample, this is a sample problem on LeetCode somewhere. Some of the problems, some of the solutions, I don't know. I like this question is so obviously a generator problem to me. I'm sure you can find a solution on there that uses a generator. I don't know if it's in C++, to be honest, but I'm sure you can find at
Mm-hmm.
least a Java or a Python solution that uses generator, or they call it iterators there too. So
I
you can
see.
try
I
to
see.
find a sample solution there to compare.
I see. Sounds good. That makes sense.
Cool.
That's great. Thank you so much.
No worries. Yeah, I mean, good showing today. I think overall, I mean, remember, right, there were two problems you did today, right? So I think
Mm-hmm.
it was overall pretty strong showing, but yeah, it's a bit of a technique thing on the second question. Technique, yeah.
Sounds great. Mm-hmm.
Great.
Sounds great.
Thanks for your time.
That's great. Thank you so much. And are you coming tomorrow for the meetup?